Good evening, everyone. My name is Ajai Ahluwalia. I'm the head of supply chain at RenewableUK, but I've worked in the offshore wind industry for over 13 years. I'm going to talk to you today about offshore wind, and there are 3 key messages around offshore wind that I want you to take away. Number 1 is that offshore wind can be and will be the biggest way that we can decarbonize our energy system. The second point is that the cost of offshore wind has significantly reduced over the last decade, and that it can help to reduce people's energy costs. And the third thing is that offshore wind isn't just about the spinny things, i.e. turbines, but actually there's a lot more to it than that. So a little bit more about me first, and hopefully you can see that I've put an embarrassing picture of when I was at university. So I studied engineering at Loughborough University and looked at wind power as well as wave power as well, which is what is in the top left-hand corner. But over my career, I've worked in the military defence sector, developing fighter jets, but also working in the oil and gas sector, which I was sort of required to do in order to get my foot into the door into renewables when it wasn't quite as large as it is in terms of the industry. So what you see in the top right-hand corner is the Rough field, which is actually the UK's largest gas storage field as well. I've worked for various companies like Centrica, Scottish Power Renewables, Equinor, formerly known as Statoil, but for the last 13 years I've worked in offshore wind, designing, developing, constructing and operating offshore wind farms, and looking at other things like energy storage as well. So what is an offshore wind farm? Before I jump into this, I am going to do a little bit of physics. I know, right? So sometimes we often use terms like gigawatts and megawatt hours, and I think one of the things I just want you to take away from this is what sort of unit is this? So do most people have a microwave at home? Yep. Okay. So some of your microwaves might be 1,000 watts or 1 kilowatt rating, right? So if you think imagine your microwave was running for an hour, that would be a kilowatt hour of energy used. Now, often in energy, we refer to large units or megawatts or gigawatt hours, so 1 million watts or 10 to the 9 for your giga. Just bear that in mind. But if you want to think about it in terms of a house, thank you. If you want to think about it in terms of houses, statistics show that approximately a standard house, domestic household, will use about 3.5 megawatt hours per year. So just have that in the back of your mind. Right. So offshore wind farms. Let's start with the big spinny things. Turbines, wind turbine generators, not windmills. One of my proudest moments is when my parents stopped calling them windmills and started calling them WTGs. My dad literally called it a WTG, and I just went, whoa, he's learned. These are obviously the things that generate the power in the first place. When I first started in the industry, the first offshore wind turbine I worked on was 3.6 megawatts. And the last project I worked on actively as an engineer was a Dogger Bank wind farm, which will be the world's largest offshore wind farm at 3.6 gigawatts. So huge figures. If you think about Hinkley Point C, which is one of the nuclear power plants that's coming online soon, the same sort of rating with regards to that nuclear power station. So what happens then? You connect it via what we call array cables. So cables that connect it to a centralized offshore substation. So you've got cables there, array cables. You've got a substation, offshore substation, where your voltage, the power associated with your wind farm, where the voltage is stepped up. Why? So you can reduce your transmission losses to the onshore substation. Bear with me. Essentially, a substation. These can be HV, high voltage, alternating current substations, or high voltage, direct current substations as well. If you want to know more about that sort of stuff, we can talk after, if you're interested. In any case, you transmit that power via what we call export cables to your onshore substation, where again it's either stepped up or transformed back to a voltage that then connects into the national grid. Okay, so that's the general principles of what an offshore wind farm is. And what I've shown you there, or what I've tried to show you there, is on the right-hand side is just an appreciation of how large these assets are. So on the last wind farm I was working on, Dogger Bank, these turbines are sort of 13, 14 megawatts big. From the tip height of the blade, it's almost the same height as the shard. That's how large these turbines are. The high voltage direct current substation off there weighs in excess of 10,000 tons. And what you have there is the vessel that's lifting it onto the jacket foundation. That's one of the biggest cranes, offshore cranes in the world. These are mega projects. that cost billions of pounds. So, energy production. Okay, we're building all these offshore wind farms. What for? Okay. So again, I'm going to talk numbers. Forgive me. If you think about the UK's daily average in terms of power, or sort of the average power that we consume in the country, it's 32 gigawatts. So just think about Dogger Bank, 3.6 gigawatts. That's one very big offshore wind farm. That would almost be providing, sort of tenth, or just over a tenth of what the UK's sort of consumption would be. We peak at 42 gigawatts. Does anyone, are people aware that when you get back home in the middle of, and it's night, people, put their kettle on, put their heating on, turn the TV on, it's dark. That's when you see that sort of peak. So we sometimes call it the swan curve in regards to energy consumption as well. And we could talk about demand side response, but maybe that's another talk. But then, where do we stand today? So approximately 40% of the energy, and I did a quick analysis using Drax Insights website there. So for over the last year, about almost 40% of the UK's energy in total came from renewables, and that's a huge achievement. I know that we're here and we're all a bit anxious about climate change and various other factors, but one of the messages I want you to take away from today is that actually the UK is one of the leaders in the world when it comes to decarbonising the energy system. In this case, it's the electricity system, and energy is more than that, transport and heat as well. But when it comes to electricity, the UK is leading the way. A lot more we could do, don't get me wrong, but we are doing okay. And bringing it back to wind, we see about 27% of the UK's energy coming from wind in that last year. So just another benchmark in terms of how much offshore wind we have. We've got about 13.8 gigawatts installed at the moment, of another 6.5 gigawatts in construction. There's a lot more offshore wind that's in the planning phase and is backed by what we call a CFD, or a contract for difference, and this sort of ties into how it makes it relevant for businesses to invest in their projects. And then another key message I just wanted to get across was the volatile nature of energy costs at the moment. We're all acutely aware of the cost of living crisis and how inflation and a large aspect of that is related to energy costs as well. The volatility of our energy prices is significant simply because of the amount of gas that we use to power our system. So the cost of our energy system at the moment is a function of the price of gas. Until we decouple electrical power or renewable energy via electricity from that gas market, we won't see the massive changes we require. So just another point relating to policy then. This whole sort of narrative of, are we doing enough? I was talking to some colleagues in the crowd before. My opinion, personal opinion, is that we are doing a good job. We are world leading in many ways, but there is significantly more that we could do if we want to actually achieve the targets that we are seeking to do. So if you're familiar with organisations like the Committee on Climate Change, they are constantly sort of talking to our government at the moment and saying, you're not going to achieve the targets that you're legally obliged to make. The government recently responded to that via the Powering Up Britain report that came out in March, which addresses some points, but we are behind the curve. And more recently, what we've seen is the Offshore Wind Acceleration Task Force, which has been there to identify what some of those key issues are, which I'll talk about on the next slide. But just to give you an order of magnitude, in 2019, the industry decided we were going to aim to have about 30 gigawatts of offshore wind by 2030. In 2020, that was increased to 40 gigawatts of offshore wind, including 1 gigawatt of floating offshore wind. And just this year, or in fact the end of last year, the government has now increased that to 50 gigawatts of offshore wind by 2030. So within the last 2 years, our target or our ambition has increased by a further 20 gigawatts. So the challenge is enormous, and we are doing everything we can do, but we do need more support. Actually, there's one other thing I wanted to talk about, the cost. So the way that we build these offshore wind farms, you have to have a business model. These organisations don't build them for free, they're not charities. Now, the way that they construct their business models is essentially focused on something called the contract for difference. What's the contract for difference? It's essentially a government-backed support mechanism, not subsidy, support mechanism, which makes sure that your revenue stream associated with the megawatts that you're generating is consistent. So for the first 15 years, the government is essentially saying that for every megawatt you generate, you're going to get a fixed price per megawatt hour. If you'd like to talk to me about that later, then more than happy to. But the key thing is eliminating the risk associated with your revenue stream, which allows businesses to invest in these types of projects, because we are talking literally billions of pounds. And the key thing with offshore wind today is that we have reduced the cost so much that literally in the last allocation round last year, we saw the lowest ever prices of just over 37 pounds per megawatt hour. Now, if you think back to my previous slide where I identified, I think it was 460 pounds per megawatt hour, those ridiculously high prices, then what you'll hopefully see is that if we get more of that cheap renewable energy, offshore wind in this case, then we can help to reduce the burden on the UK's consumer. So, challenges. Two big ones I wanted to talk about. The grid. So I'm an electrical engineer by background, so I love talking about electricity, clearly. The way that we connect to offshore wind farms at the moment is you literally have one connection from the wind farm to the onshore substation. But because of the scale and the size of what we want to do, we've got to have a coordinated system. That means less disruption to people in terms of cables being installed across people's areas, but also it's a cheaper, more effective way of building out the grid. So what the picture on the right-hand side shows is a vision that's been produced by National Grid, where you see all those offshore wind farms connected via an offshore grid, essentially. And that's one of the things that we're pushing. Now, you can have a design, but the policy behind that and what drives that, who builds it, who benefits from it, there's lots of questions in and around the policy sphere that still need to be answered to make that a reality. Picture on the left-hand side is an artist's illustration of a port. So I'm now working in the supply chain side of things. And for me, a key thing is, okay, we've got these huge ambitions around developing offshore wind. But then what the other benefit of that is, well, we need to secure that supply chain to make sure that in this global market where everyone wants to build increased grids, offshore wind, that actually the UK can make sure that its own domestic requirements are met, and where possible have an export market as well. So I'm really keen, and what I'm looking at on a daily basis is how can we make sure that the UK's supply chain requirements are met. But in conjunction with that, if we are able to construct these factories or these ports that allow us to do what we need to do, then we're creating highly skilled, well-paid jobs as well. So one of the key messages I wanted to get across is that not only are we solving the problem of climate change, touch wood, but we're actually hopefully going to solve a lot of socio-economic issues in the country as well, where we do see highly skilled, well-paid jobs, not just in London or the cosmopolitan centres, but in some of those less, well, forgive me for saying it, more deprived areas in those sort of coastal areas as well. So please take away the message that actually if we do this right, we can solve a lot of other problems other than climate change. Thank you very much.